This is our project of a modern beverage vessel. Our team is a collaboration of industrial and civil engineers. Our project manager and lead designer is Wang. One of our civil engineering collaborators and human factors lead is Nguyen. Our market expert and manufacturing lead is Abigail Heron, and another civil engineering collaborator is Jack James. Many beverage tumblers are not properly sized for optimal flow, which can lead to spilling on the user of the beverage vessel. Containers also often leak and create unwanted stains and messes. Beverage containers that maintain temperatures are often very expensive and can transfer the temperature to the user. Too many of these tumblers also do not have sufficient grip. These are the problems that our design team took on as we wanted to create a beverage vessel that had much better characteristics than previous ones that have come onto the market.
The primary problem is to control temperature, so we use a common design in the market, the double wall. In our design, the inner wall is metal and the outer wall is plastic. So in this design, there is a vacuum insulation space between two walls, so it could sufficiently reduce heat transfer since there is no particle for heat conduction and convection.
One major issue with common beverage containers is the fact that many of them leak and allow droplets to go down the cup and then create puddles at the bottom. So we wanted to prevent that by putting a droplet catcher on our beverage container. Now, a big issue with this was figuring out the proper size to make the beverage droplet catcher to catch enough of the liquid that would escape from the tumbler. We wanted to be able to hold a total of 10 droplets, and we assumed that each size droplet was the size of a raindrop. So from that, we were able to calculate out the total volume required to hold that amount of water. And after all of our calculations, we found out that the required dimensions of our droplet catcher going around the entire outside of the container would be 0.0007 inches to be able to hold all of the liquid.
To expand market share, we decided to make decoration on outside wall. As you can see, we could print out a landmark of the university logo or pencils on the wall. So for the people who want to personalize their cup, we could satisfy their requirement. And it is the lowest cost way to personalize coffee cup since we don't have to change the design of the bottom and we only need to change the printing.
One of the major issues we wanted to address in our design was the common problem of the opening of the lid for beverage containers not being a sufficient size so that the liquid inside of the container oftentimes comes out and rushes out and spills onto the user. So we conducted a flow analysis to optimize the size opening of our lid. We used basic physics and free body diagrams with a couple assumptions of the beverage vessel being 95% full and being used at a 45-degree angle to compute the amount of pressure and force that the liquid would be putting on the lid of the container. Then we did another analysis and determined that the opening area required to be 0.114 square inches, which would give a flow velocity of 30 inches per second. We deemed that this velocity would be too high, so we reanalyzed the lid with the assumption that we want our flow to be 20 inches per second. With this velocity, a required area is 0.19 square inches, meaning that the diameter opening of the lid will be 1/2 inch.
Given that our product is a beverage vessel, we wanted to take into consideration the major tasks that our product had to fulfill. One of the most obvious is that it should be able to hold the liquid that the user wants to put into our product. The following task is that it wants to prevent the spill, and that is taking into consideration human errors, such as accidentally tipping it over, and when they do that, the liquid will not spill over and mess everything up. The last major function is to regulate temperature. If the user puts in either a hot or a cold beverage, the insulated walls mentioned earlier will keep the temperature as it should be.
Our target market was people on school campuses. There are many coffee cups on the market that exhibit a variety of features, most of which we tried to include in our cup. Prices vary for different cups, but range from around $5 to a more expensive end of $150. Cups in our market that we found comparable to our cup were that of the Golchi Thermos, which was $32, the Yeti Contigo, which was right around $30, and a Hydro Flask, which is $45. Our goal for price would be from $25 to $30.
Next, we're going to look at human factor considerations and rationale. The first is safety. We're going to create labels with instructions at the bottom of our product and put paper copies inside our product. We also wanted to prevent injuries from the hot liquids. Next, we wanted to look at using the product. We took into consideration the ease on the user when opening and putting on the lid. We wanted to avoid the strain on the wrist. Next is holding the product. We wanted to avoid carpal tunnel, as this proves to be an issue when constantly holding objects. Following that, we're going to look at maintenance. Opening of the coffee cup, the opening of the coffee opening. It's going to be designed to adjustability. Next is going to be dishwasher safe. Next is going to be aesthetically pleasing. A product with a nice design tend to affect more users and increase sales.
Next, we have some renderings of our product.
For our design, we used a double wall insulator. The inside material is metal and the outer layer is a clear plastic. Our materials must be non-conductive, able to keep hot drinks hot and cold drinks cold, and lightweight. Stainless steel will accomplish this goal for the metal component. The outer layer with the decorative element will be made of a clear PVC. The metal layer of the cup is rolled to form the shape, and the plastic layer is made via injection molding.